What's up, guys? Welcome to another Maker Monday. Hope you guys are having a good weekend, or at least had a good weekend. Hopefully we're starting off the week again with another wonderful Maker Monday. Hopefully you guys are having a good week. This week on Maker Monday, we are going to be talking about relays and relay protection. A lot of people don't know this. In fact, I know I didn't know this. Even when I was young and in college and everything, thought I knew everything about everything because of all the books and everything that you read. You don't teach certain things. In fact, I was kind of amazed, at least where I was at, they just barely touched on protection circuitry. And I may do a whole nother video on this. This is just a quick glimpse since this is one of our Maker Mondays. Let me go ahead and start my watch. We're going to start the timer. Make sure I don't go over. There it is. So since this is a short movie, I'm just going to show you one thing because there's a whole entire science to protective circuitry. So diode protection, TVS protection, lightning protection, input power protection, over voltage protection, under voltage protection, all that jazz. I could do an entire, probably hour-long video on it. So we're just going to touch on one, and that's a very simple one. Lots of people like using relays, especially if you're dealing with mains voltage. So like, the 120 volt AC or something like that. A lot of times it's a lot easier to just, if you're just wanting to turn something on and off, to use a relay to do that. As well as sometimes it's easier to get your hands on a relay. In fact, I think I've got, one of those relay modules around here somewhere. Well, I thought I had one. Maybe it got lost. I don't know. I had one of those big, oh no, there it is. It was hiding. One of these, you have these. Well, if you notice, if you look really close on one of these, there's little diodes there. Why? Well, I'm going to show you why. We're going to go ahead and go to the bench. I've got some things set up. Believe it or not, these are actually solid. This is by the way, this is an automotive relay, which is a great relay, by the way. Automotive relays are fantastic. They're not very expensive. They're only, I don't know, maybe $3, $4, and you get them from your local automotive store. Heck, I think you can even get them from Walmart if I remember right. You can just pick them up in the automotive section. They're a good, strong relay. They're 12-volt coil, and yeah, they can take quite a pounding. They can take, I can't remember how much it is. It's like 20 or 30 amp. I mean, it's a lot. They can take a pounding, and they're not very expensive, and they're readily accessible. You can get them kind of anywhere. And they have these cool little stake-on connectors on it. So if you have those little slide-on terminals that you can crimp, which I've got a whole kit of them, you can get those off Amazon. You can slide on wire connections, and there you go. It has multiple points. It's got normally open, normally closed points, and everything on it. They're a very good little module. So I highly recommend that. If you can't get your hands on one of these fancy relay modules that has everything already in it for you, and it's all mounted to a PCB, get one of these. These work fantastically. I've used them a lot. In fact, that's why I have one just laying around here in the shop. So what we're going to do is I'm going to show you how to protect your circuitry with this, because I don't know if many of you have tried this, but if you try to MOSFET control one of these, or heck, even BJT, but you try to use a transistor control it, you might be blowing transistors and have no idea why. You'll switch it and it switches fine, but about maybe the 10th, 15th time you switch one of these guys, your MOSFET fries. What in the world? Right? So what we're going to do is we're going to take a look at why that it fries your MOSFET. Why that's a problem, okay? And there's a very, very obvious reason. These are solenoidal actuators inside, which means they're a solenoid, so they're just wire wrapped around a tube, basically, that creates a magnetic field. It has a plunger inside that tube, and when you actuate it, when you energize it, the magnetic field sucks the plunger in or pushes it out, depending on which way they've got it oriented, and that moves the contacts back and forth, and that's what makes and breaks the connection inside these things. They're a purely mechanical device, which is why they wear out, which is why we try to, in electronics, we'll try to use like FETs or something like that, because they don't have the mechanical component. They don't have friction that will cause them to wear out as quickly. However, these are cheap, they're big, they're beefy, they can take quite a pounding, and the benefit of a relay is it gives you electric isolation. When the contacts break, it physically disconnects the circuit. Whereas with a MOSFET or whatever, you just have N and P type material, and you're relying on the way the charge works. If you haven't watched, I have a video on MOSFETs and how they are constructed and whatnot. And you're basically relying on silicon isolation, which silicon, as we know, is a semiconductor. So you can get situations where voltages get big enough and things like that that it can actually punch through it anyway. Well, with one of these, you are physically disconnecting the circuit. It would have to get, I mean, we're talking thousands of volts to arc across the set of points that's inside this thing. So relays are very good. So let's go ahead, without further ado, check out the bench. I got some set up here, and we'll look at what I'm talking about and why these might blow MOSFETs if you're trying to control them with them, and what you can do to protect against that. All right? So let's swing the camera on over here and we'll check out the table. Okay guys, so here we are at the bench, got our relay. I just kind of hooked up a breadboard just so I could hook up this little guy, because I don't actually have a wire that hooks it up to the power supply. I got 12 volts on a power supply. I actually hooked up a meter probe. Those of you that don't know, most power supplies have those connectors. They're the same as a probe. So I'm going to use this probe to touch the 12 volts to it to get it to click, just like if I was switching it. So now, how we hook this thing up, if those of you can see it. All right, so here's our coil. Our coil is right here. So it's between this 85 and 86, and then our contacts are between 30 is the common, we've got 87 as the normally open, and 87A as the normally closed. Now, we're not going to be hooking anything up. I'm just going to show you what will happen when you energize and de-energize this thing. So what actually happens is you get what's called an inductive overspike. The minute that you collapse the electric field across a coil that's in here, you actually, remember, it's like an inductor. And remember, an inductor is, I don't know if you remember that saying, that Eli the Iceman, but Eli, which is electromotive force, or EMF, which is the same thing as voltage, is equal to the inductance times the derivative of the current with respect to time, which means the change in current over the change in time. So therefore, you cannot change the current across an inductor instantaneously with time. Okay, is what that means. So how can it keep the current steady? Well, if you know V equals IR type situation, the R is set because of the resistance of the wire in the coil. The current is set because of the inductance law that I just said. So if the current has to decay with time, then the voltage is going to have to fly all over the place for the current to remain constant until it finally decays out. So that's why you get an overspike, is the minute you de-energize one of these, you're going to collapse that electric field, which is going to cause the current to zip to zero, but due to its inductive nature, you cannot collapse the current instantly by removing the power. It's going to give up some of the magnetic energy that it has stored, the current, that it is stored in it, and it gives it up as current to keep the current solid. Well, what happens is the voltage flies all over the place to keep the current solid, and we're going to see that. I've got a scope set up. I'll move the camera and zoom in here in a minute, but basically to show you, see if you can hear it. So it's working. So what we're going to do is we're going to hook up a scope. So we're going to hook up a ground, we'll hook up the main probe to the scope. All right, so now what I'm going to do is I'm going to zoom in, or at least move up to our scope up here. All right, so what I'm going to do with our scope, and I'll zoom in to show you this, is I'm going to set it in single shot mode after I touch this to it. So we're going to turn it on. So we got 12 volts up here. I'll zoom in here in a minute. And so I'm going to put it in single shot mode, which it'll capture when there's a change. So now I'm going to take the energy away. Right now it's energized. Now I'm going to de-energize it. So it's a heck of a spike. Let's look. Let's see if I can get this to actually go down there. Yeah, minus 88.8 volts. I don't know if you can see that, but right here. So minus 88.8 volts. Wow, that's a lot. That is huge. So that, and now if you have a gate to source voltage that's only 20 volts, that's just going to blast that. So that's 88 volts. And remember, this thing's got current behind it because it's stored up the energy. So there's current behind this voltage too. So that is going to just blast your MOSFET. So it's going to punch through the gate to the source. Usually is what happens on an N channel, definitely. It punches through the gate to source and ties those together and shorts it out, and then it's done. So that's what's happening to you. Now, how do we protect against it? A very, very easy, very simple way that we protect against this is the diode. Now this diode, I believe, is a 1N4007. Yes, looking, make sure. Yep. So 1N4007. It's a 1,000 volt diode, so it can withstand 1,000 volt spikes. So that's plenty. If this is only going up to 88, maybe 100 volts, that is definitely plenty protection. Now, what you want to do is you want to stretch this with the anode. Let's see, hopefully I say that right. I always get anode and cathode mixed up, but the striped side, which I believe is the anode, the cathode, sorry, my bad. I believe the stripe is the cathode, and then the anode is the N. Forgive me if I'm wrong. I'm sure somebody in the comments will correct me. Anyway, so the striped side, which should be the output of it, which should be the cathode, goes to where we're putting the voltage, and the anode goes to the ground. So what I'm going to do is I'm going to hook this to the ground, shove it through this little hole in here so it makes connection. Okay, so I just wired a diode across the coil. So now let's see what happens, if anything. So I'm going to re-energize it. I'm really not even getting anything. The scope isn't even triggering. So I'm going to go ahead and just run it. Is a nice sharp transition. See if I can zoom in on that. Zoom in. Move that over. Move this over. Zoom in. Look at the transition on that. It's nice and sharp. Transitions from 12 volts to 0 volts quite nicely. Now if I can get it back. There it is. There it is. There's either that, or if it is there, it's very, 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 very small. Inductive overspike. And that's due to the diode. What the diode does is it does not allow that to reverse. Remember I put it through from the positive to the negative. Remember it was going negative about 88 volts. The diode disallows that to happen. So you only get just a little bit of a transition, maybe a tiny little dip. I mean, barely even anything. Yeah, like -2 volts. Well, totally, it can handle -2 volts. So as you can see, that takes care of it. The diode fixes your problem. Okay guys, so that's basically how the relay works and how you can protect against that with just a simple 4007 diode. Well guys, I hope that you enjoyed this. I hope that it didn't run too long, but I hope you enjoyed this. It's a little tidbit of information. Hopefully it started your week off good if you're watching this first thing in the morning, or at least at the end of a long Monday, if your Mondays are anything like mine. It at least gives you something to watch and to kind of unwind to. All right guys, thank you very much. Please support the channel. Hit that like button. Give a thumbs up or thumbs down as you please. Make sure and leave comments. I love listening to your comments. Oh, I wanted to tell you something really fast. Sorry, I might be going over to tell you this, but here we go. I've got, like most of you know, if you follow me on Twitter, I got into Boy Scouts and whatnot, or really Cub Scouts because of my son. So we're doing our popcorn sales. So if you want to support Cub Scouts and all that stuff, and really Boy Scouts of America too, and support that, I'm going to leave a link down in the description to my son's popcorn sales thing. You basically, I look at it as you donate money and we give you popcorn. Because the pricing is a little steep on it, but really it's all for supporting Boy Scouts of America and supporting our local Cub Scout pack. So if you would like to do that, hit that link down there. We sure appreciate it. If not, that's fine too. Thank you very much for all of your support, guys. Take care, keep coding, keep building, because that's what it's all about. Oh, t-shirts, make sure and check out the t-shirts. Coffee cups, we got coffee cups. We got a coffee tumbler, which I really enjoy. In fact, I bought one. I even had people at my work buy some, as well as they bought t-shirts at my work too, because they saw my t-shirts. So if you need a t-shirt or want something else, help support the channel. All those proceeds go to support the channel, buying more stuff for me to bring to you guys. Check that out. Hit the Bitcoin thing if you want to donate Bitcoins. That helps out too. That helps out a lot. All of it helps me buy more equipment and things for you guys. That's really what I buy it for, because I honestly don't use any of this for anything else. Maybe 1 or 2 things will come up that I'll use this stuff for, but really it's mainly all for you guys. So hit that like button, hit that subscribe button, share the videos everywhere, and we will catch you next time. Thanks a lot, guys. Take care, and we'll see you.